Hey guys, it's Mrs. Burnth here, and it's been a while since I've seen you guys. See me, Mrs. Burnth? It's been a while since I've seen you anyway, so, I want to tell you that, cold is coming to the weather, and I want to teach you about calculus, and I'm going to continue on calculus, so, yeah, I'm just going to continue on calculus because, I kind of missed it for the last time, so I decided to do a calculus, maybe do our calculus, take the test on calculus. I'm not giving you the answers on calculus because you guys know it. It's private, you know. You don't want to see it. Nissan and Lion, they are doing good. Nissan has to get up in the morning for school. Nissan is really physical. He can try to hit me, and I grab his hand and be like, Nissan, you better stop, okay? This is why I don't allow hitting, because hitting is not okay. You should notice in daycare that you're not allowed to hit, okay? So if you have any questions, just let me know, and I'll put my Mrs. Burnth account and just say it all you want. Just don't say anything mean. Just say something nice, okay? I know it's been a while since I took a break for a little YouTube. I know it's been a while. I'm just gonna pretend that it's like a late assignment I have to do every day. It's not easy wearing this mask all the time, and it's very, very difficult for me. You have to wear your mask from now on in a building. The COVID might end at like next year, I think. I don't know when, but it will end, I promise. Since this COVID started, I was like, oh no, what am I gonna do? And I just don't really get it. I just don't really get it about the COVID at all. It's like a bunny rabbit chasing a bear. You know? Like, you ever heard of something that is chasing a bunny bear? I don't think you do, because I think I'm gonna show you. A bunny bear is chasing the hair on the ground, and guess what a bunny rabbit does? He just eats it. Or she. It's not matter what it is, but it might be successful if you just try it. Try your luck. I'll just give 3 habits of mind that will show you an example of the American way. You know it? I'm going to show you the American way. I have to show you a bit ideas, and I'll show you a little bit ideas if you want to. If you can just scroll down with me and I'll get to U.S. history. I know the presidents are not, many who have voted for Biden, or how do you say it, or Biden. Many people like Biden better than Trump because Trump is because Trump is not that bad actually. Quinn doesn't really like Trump, so a teacher has her own opinion, so be kind, okay? If you don't like it, then that's fine. I can keep my mask on if I want to. For my face right here. You can see my eyes, but you cannot see my mouth because I don't want my nose bleeds out, so let's just do the right way. Don't mind if I do, because my legs are going shot as far, that's why I keep doing it. Quinn has been doing good so far, and he's been working on his assignments. If you really do get to work on your assignments, you might get an A+ for your 8 classes. Just like the teacher said, if you want to pass, you gotta get a credit, man, like a full credit, like a credit on a piece of paper. You got it? So if you have any questions, just let me know, and we're about to get started on the calculus. Let's just get this thing over with. If you want to go any questions. If you have any questions or concerns about me, just let me know and I'll go slow them down for you. But, in the matter, I'd rather just let you know, kids are not allowed to leave early because I'm going to be blocking the door. Just let you know, I told you guys that back in the part, I think it's part 4, 5, or 6, I don't know. Alright, let's just get things over with, and I don't even know how much time we have left, so. Make sure if you have any questions, make sure to ask questions, ask away, and I'll answer them right away. If you contact me on YouTube, it's better for me to reveal your answers or your questions, and I'll answer for you, like 30 minutes or so, if I can try doing them all, like a different size or something. But it's only a matter of time, you know, you ever seen like a 101 Dalmatians? That's the dogs I'm talking about, guys. We must work on their bulldog way. Respect, responsible, and relationships. Sorry about that. Yeah, people are getting sick from the coronavirus, and the coronavirus is a strict way to stay in our assigned seats. We're gonna have to change it up a little bit. We're going to send in assigned seats. We're gonna do it as we're told on this COVID thing. If anything cannot get changed for this COVID thing, then it's the way that it's been changed so far. I don't know why it would have to happen, but this is one of those things. This is one of those things that you don't want to get in trouble for. Many people get in trouble for doing something that they're not provided for, or something that they've never done. If they have any questions questions or so. Maybe we're going like crazy Japanese on it. I might teach you some Spanish levels, or how can you talk to someone in Spanish demeanor. Like I have a lot to teach, so if you'll excuse that, I have to teach elementary students, and middle school students, and high school students, and college students. I'm going to teach about Algebra 3. Algebra 3. Algebra 4 does not exist. Maybe you don't think so. You don't think Algebra 4 exists. There's no such a thing as Algebra 4 because I don't remember having an Algebra 4 out. But point is taking Algebra 3, so Algebra 3 kind of exists, I guess, if you have any questions or so. Any questions about the calculus? How's it going to go? Alright, let's get on to it. Alright, I'm just going to move my camera just a little bit. So be aware of something. Yeah, just be aware or something that you want to check out. Sorry about that, the frog was in my throat. I had to get it out. Oh, just kidding. I had to fix my mask here, so let's look at the calculus problems that we have to do. Alright, let's look for some calculus problems. Calculus 1, different problems, different formulas. Section free. Differentiation formulas, practice problems. Alright, let's just go with number 1. Okay, so I have just been informed that Lamer University needs to perform energy work on the internet here. Because of that, there is a high probability that the site will not be reachable on a Saturday, October 24th for 8 o'clock to 10 p.m. Central Standard Time. I apologize for the inconvenience. October 23rd, 2020. Okay, so find the derivative of fx equals 6x 3 squared minus 9x plus 4. Okay, so there isn't much to do here other than take the derivative using the rules we discussed in this section, fx with parentheses. I'll show you what it looks like. Yep, that's what it looks like, see? Look, that's what it looks like. A different size of it looks like. That looks so much better. La. It says x with parentheses and equals 18x 2 squared and equals 9. So that's how you find the derivative formula that is showing on his list. So yeah, let's do another problem. I want you to think really hard for me, okay? Alright, number 2. Differentiation formulas. Practice problem solutions. Find the derivative of y equals 2t 4 squared equals 10t squared 2 plus 13t. Alright, we got the show solution. There isn't much to do here other than take the derivative using the rules we discussed in this section. dy divided by dt equals 8t third squared minus 20t plus 3 plus 13. Sorry about that. Alright, so this is what it looks like. This will be reviewed on your test. So if you need any questions, just let me know, and I'll work them out for you and just get them all done. Yeah. Alright, let's do number 3. Find the derivative of z with parentheses equals 4z 7 squared equals 3z negative 7 squared plus 9z. Alright, there isn't much to do here other than taking the derivative using the rules we discussed in this section. z in parentheses, equals 28z 6 squared plus 21z negative 8 squared plus 9. Alright, this is what it looks like. I know you can't see it a little bit because it's too bright here. Alright, let's find the derivative of hy in parentheses equals y negative 4 squared negative 9y negative 3 squared plus 8y negative squared plus 12. There isn't much to do here other than taking the derivative using the rules we discussed in this section. Hy in parentheses equals negative 4y equals negative 4y negative 5 squared plus 27y negative 4 squared minus 16y negative 3 squared. Alright, so I'm going to say it this time. Alright, let's do a 5. Okay, so there isn't much to do here. Find the derivative of y equals, okay, so y equals fractional point x plus 8 free top fractional point x minus 2 4 tops fractional x. I'll show you what it looks like. I'm not showing you the answers, but you have to know it first. Okay, so remember that you'll need to convert the roots to fractional and exponents before you start taking this derivative. Here's a rewritten function: y equals x 1 divided by 2 plus 8x 1 divided by 3 minus 2x 1 down to 4. Okay, so the derivative is dy divided by dx equals 1 divided by 2x negative 1 divided by 2 squared plus 8 divided by 3x negative 2 divided by 3 squared negative 1 divided by 2x with negative 3 4 squared. So that's how you get this done. That's how you learn for calculus. Alright, so find the derivative of fx in parentheses equals 10 5 tops fractional point x3 negative or minus fractional point x7 plus 6 3 tops fractional point x8 minus 3. Remember that you'll need to convert the roots. You have to do the same thing. Okay, so here's a rewritten function. The derivative is fx equals 10 x3 in parentheses 1 5 squared minus x7 1 2 squared plus 6 x8 in parentheses 1 3 squared minus 3 equals 10x 3 5 squared minus x7 squared 7 2 squared plus 6x 8 3 squared minus 3. The x in parentheses equals 10 3.3 3 divided by 5 x negative 2 divided by 5 squared negative 7 divided by 2x 5 2 squared plus 6 8 divided by 3x 5 3 equal 5 3 squared equals 6x negative 2 5x okay negative 7 2x 5 2 squared plus 6 what 16x 5 3 squared. Sorry for saying it wrong. I'm gonna try my best. Where was I? Find the derivative of 5t open parentheses equals 4t minus 1 divided by 6t free squared plus 8 divided by t5 squared. Remember, you'll need to rewrite the terms so that each t's are in a numerator with negative exponents before taking the derivative. Here's a rewritten function. The derivative is ft equals 4t negative 1 squared negative 1 6t negative 3 squared plus 8t negative 5 squared. Ft equals negative 4t negative 2 squared plus 1 2t negative 4 squared minus 40t negative 6 squared. Rz equals 6 divided by fractional point z3 plus 1 divided by 8 z4 squared minus 1 free z10 squared. Okay, so you'll need to rewrite the terms so that each of the z's are in a numerator with negative exponents, and rewrite the root as a fractional exponent before taking the derivative. Here's a rewritten function. The derivative is rz equals 6z negative 3 2 squared plus 1 8z negative 4 squared minus 1 free z negative 10 squared. Rz equals 6 open parentheses negative 3 2 z negative 5 2 squared plus 1 8 negative 4 in parentheses z negative 5 squared minus 1 free negative 10 in parentheses and z negative 11 squared equals negative 9z negative 5 2 squared minus 1 2 z negative 5 squared plus 10 free z negative 1 negative 11 squared. Okay, so I'm barely making it. Find the derivative of z equals x open parentheses 3x 2 squared minus 9. Remember that in order to do this derivative, We'll first need to multiply the function out before we take the derivative. Here's a rewritten function. The derivative is z equals 3x squared minus 9x. The derivative is dz divided by dx. You remember the y equals mx plus b? That's what you should do in algebra. You should have taken that. You should have learned that in algebra or pre-algebra, I think so. 9x squared minus 9. So that's how it works here in calculus. Okay, so let's do 10. Find the derivative of g, y in parentheses equals, in parentheses, y equals y minus 4. In parentheses, 2y plus y squared. Remember that in order to do this derivative, we'll first need to multiply the function out before we take the derivative. Here's a rewritten function. The derivative is gy equals y3 squared minus 2y2 squared minus 8y. The derivative is gy in parentheses equals 3y squared minus 4y minus 8. Find the derivative of hx equals 4x 3 squared minus 7x plus 8 divided by x. Okay, so in order to do this derivative, we'll first need to divide the function out and simplify before we take the derivative, or derivatives, how do you say it? Here's a rewritten function. The derivative is hx equals 4x third minus 7x plus 8, 4x 3 squared divided by x, 7x divided by x, 8 divided by x. The x are all in free, so yeah, negative 4x squared minus 7 plus 8x negative 1 squared. Okay, so the answer is x in parentheses equals 8x minus 8x negative squared. I need my glasses. Find the derivative of fy equals y5 minus 5y3 squared plus 2y divided by y3. Remember that in order to do this in derivative, we'll first need to divide the function out and simplify before we take the derivative. Here's a rewritten function. The derivative is fy equals y5 squared divided by y3 squared minus 5y3 squared divided by y3 squared plus 2y squared divided by y3 squared and equals y squared minus 5 plus 2y negative 2 squared. So the answer is fy in parentheses equals 2y minus 4y negative 3 squared. Okay, so determine where, if anywhere, function fx equals x3 squared plus 9x squared minus 48 squared, or not 48 squared, or minus 48x plus 2 is not changing. Okay, so recall that one of the interpretations of a derivative is that it gives me a rate of a change of a function. So a function won't be changing if its rate of a change is 0. So all we need to do is find the derivative and set it equal to 0 and determine where the rate of the change is 0, and hence the function will not be changing. Fx equals 3x squared plus 18x minus 48 equals 3, in parentheses, x squared plus 6x minus 16, negative 3, or equals 3, x plus 8 in parentheses, and parentheses again, x minus 2. Now all we need to do is set the equation to 0 and solve. Fx equals 0, 3, in parentheses, x plus 8, x minus 2 equals 0. We can easily see for this that the derivative will be 0 at x equals negative 8 and x equals 2. The function therefore will not be changing at x equals negative 8 and x equals 2. I want you to see this. This is very important. This is why it's so important. Yeah, this is why it's so important. Yeah. Okay, so determine where, if anywhere, the function y equals 2z4 squared minus z3 squared minus 3z squared is not changing. Recall in the one of interpretations, it's the same thing, okay? We have to, so a function will not be changing if its rate to change is 0. All we need to do is find the derivative to set it equal to 0 and determine where the rate of the change is 0, is hence the function will not be changing. dy divided by dz equals 8z3 squared minus 3z squared minus 6z equals z, in parentheses, 8z squared minus 3z minus 6. Okay, so all we need to do is set the equation to 0 and solve. dy divided by dz equals 0. z, 8z2 squared minus 3z minus 6 equals 0. Z equals 0. 8z squared minus 3z minus 6 equals 0. Okay, so z equals 3 plus fractional point negative 3 squared in parentheses, negative 4, 8 in parentheses, and negative 6 in parentheses. And divide by 2 in 8 parentheses. Equals 3 plus fractional point 201, 201, and divide by 16. So, function before not to be changing that. Z equals 0, z equals 3 plus fractional point 2,201. Sorry, divide by 16 equals 1.07359. Z equals 3 minus fractional point 201 divided by 16 equals negative 0.69859. So that's how it works here. So that's how it call us to do it. So yeah, we still have a few minutes, right? Find the tangent line to gx equals 16 divided by x minus 4, fractional point x at x equals 4. Recall one of the interpretations of a derivative is that to get the slope of a tangent line to the graph of a function, so we'll need to derive a function. However, before doing that, we'll need to do a little rewrite. Here's that the work as well as derivative. Gx equals 16x negative 1 squared minus 4x 1 2 squared. And answer, gx equals negative 16x negative 2 squared minus 2x negative 1 2 squared equals negative 16 divided by x squared minus 2 divided by fraction point x. Now that we rewrote the derivative back in rational expressions with roots to help with the evaluation. How do you spell derivative? Derivative. How do you say it? Derivative. Sorry about that. I kind of sound like derivative, but like a derivative. Okay, so like a now that we rewrote the derivative back in rational expressions with roots to help with the evaluation. Next, we need to evaluate the function of derivative at x equals 4. G, 4 in parentheses, equals 16 divided by 4 minus 4, fraction point 4, equals negative 4, right? G, 4 in parentheses, equals negative 16 divided by 4, 2 squared, minus 2 divided by 4 with the fractional point, and not minus, equals negative 2. Now all we need to do is write down the equation of a tangent line. YG, y equals G, 4 in parentheses, plus G, 4 in parentheses, x minus 4, and the parentheses, equals negative 4 minus 2, x minus 4, and here's the answer, y equals negative 2x plus 4. And that's how you get the step that I showed you. Stop the video and let me know if you're finished. Fx equals 7x4 squared plus 8x negative 6 squared plus 2x at x equals negative 1. Okay, so let's do this. Same thing. We have is that it gives slope of a tangent line to graph the whole function. So we need the derivative of the function. Derivative. Now we rewrote the derivative back in relation expressions. Have a little bit of the evaluation. Fx equals 28x 3 squared minus 48x negative 7 squared plus 2 equals 28x 3 squared minus 48 divided by x 7 squared plus 2. Right? Next, we need to evaluate the function and derivative at x equals negative 1. F negative 1 equals 7 plus 8 minus 2 equals 13. F negative 1 equals negative 28 plus 48 plus 2 equals 22. Now all that we need to do is write down the equation of a tangent line. Y equals f negative 1 plus f negative 1, x plus 1 in parentheses, equals 13 plus 22, x plus 1, y equals 22x plus 35. The position of an object at any time t is given by st equals 3t4 squared minus 40t 3 squared plus 126t squared minus 9. Determine the velocity of an object at any time t. Does the object ever stop changing? When is the object moving to the right? When is the object moving to the left? Determine the velocity of an object at any time z. Alright, so let's do A. Recall one of the interpretations of derivatives is that it gives the velocity of any object if we know the position function of an object. We've been giving the position function of an object, so that all we need to do is find its derivative. Well, we'll have the velocity of an object at any time t. The velocity of the object is then st equals 12t free squared minus 120t squared plus 252t equals 12t, t minus 3, and t minus 7, both in parentheses. Now that derivative was factored for later parts and doesn't really need to be done in general. Does the object ever stop changing? The object will not be moving if the velocity is ever 0, so all we need to do is set the derivative equal to 0 and solve. st equals 0, 12t, t minus 3, and t minus 7 equals 0. From this, it is pretty easy to see that its derivative will be 0, and hence the object will not be moving at t equals 0, t equals 3, and t equals 7. So, when is the object moving to the right, and when is the object moving to the left? To answer all of that, to answer this part, all we need to know is where the derivative is positive, and hence the object is moving to the right, or negative, and hence since the object is moving to the left, because the derivative is continuous, we know that the only place it can change sign is where the derivative is 0, so as we did in this section of a quick number line, it gives us the sign of a derivative of various intervals. Here's a number line for this problem. S negative 1 equals negative 384, st less than 0. S1 equals 144, st greater than 0. S4 equals negative 144, and st equals less than 0. S8 equals 480, st greater than 0. So there's negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So, and this is how it works, so yeah, I just explained it to you, so I don't need to explain it again. From this, we get to the volume rate, left movement information. Note that depending upon your interpretation of t as time, that you may or may not have included this interval. Equals two O's. Like less than t, less than 0 in the moving left portion, moving right. 0 less than t, less than 3. 7 less than t, less than 0. Negative zeros less than t, less than 0. 3 less than t, less than 7. So that's how you get the information, so yeah. Okay, so determine where the function hz equals 6 plus 40z 3 squared minus 5z 4 squared minus 4z 5 squared is increasing and decreasing. Recall that one of the interpretations of a derivative is that it gives the rate of a change of a function, since we are all talking about where the function is increasing and decreasing. We are clearly talking about the rate of a change of a function, so we need to derivative hz equals 120z squared. Negative 20z 3 squared minus 20z 4 squared equals negative 20z squared z plus 3 z minus 2. Those are all parentheses. Now the derivative was factored for later since it doesn't really need to be done in general, like I said. Next, we really need to know where the function is not changing, so all we need to do is set the derivative equal to 0 and solve. hz equals 0, negative 20z squared, z plus 3, z minus 2 equals 0. From this, it's pretty easy to see that derivative will be 0 and hence the function will not be moving at. Z equals 0, z equals negative 3, z equals 2. Alright. To get the answer to this problem, all we need to know is whether the derivative is positive and the hence function is increasing, or negative, the hence function is decreasing. The derivative is continuous. We all know that the only place it can change its sign is where the derivative is 0. So as we did this in this section, the quick number line will give us a sign of a derivative for various intervals. Here's a number line for this problem. H negative 4 equals negative 1,000 1920, hz equals less than 0, h negative 1 equals 120, hz greater than 0, h1 negative 80, h1 equals 80, hz greater than 0, h free equals negative 1080, 1800, 180, hz less than 0. For now, we get this following increasing, decreasing information. Increasing, negative 3, less than z, less than 0. 0 less than z, less than 2. Negative, decreasing, negative zeros, less than z, less than negative 3. 2, less than z, less than zeros. That's how you get these things. I'll show you what it looks like. Okay, so we have a little bit of questions left before I have to go. I'll do 2 more. Okay, so this is the second one. Determine where the function r x equals x plus 1, negative x minus 2, 2 squared is increasing and decreasing. Like I told you, we need to derivative. First, however, we need to multiply it out of a function so we can actually take the derivative. Here's rewritten function and derivative. Rx equals x free squared minus 3x squared plus 4. Rx negative equals 3x squared minus 6x negative 3x x minus 2. Now a derivative was factored if the word it doesn't really need to be done in general. Next, we need to know where the function is not changing at all, so all I need to do is set the derivative equal to 0 and solve. Rx equals 0, 3x x minus 2 equals 0, x minus 2 in parentheses. This is pretty easy, like I said. X equals 0, x equals 2. To answer this problem, we all need to know is the derivative is positive, hence the function is increasing or negative. So the derivative is consciousness, so we have to find if the derivative is 0. So varies and virtuals, there's a number of lines for this problem. R negative 1 equals 9. Rx greater than 0. R1 equals negative 3. Rx less than 0. R3 equals 9. Rx greater than 0. Increasing, negative zeros, less than x less than 0, 2, x, 2 less than x, 2 less than zeros, 8. Decreasing, 0, less than x, less than 2. So the answer is increasing. So that's how you do it. Last problem, okay? Determine if anywhere is the tangent line is to be fx equals x free squared minus 5x squared plus x is parallel to the line y equals 4x plus 23. The first thing we will need, of course, is the slope of the tangent line. So all we need to do is take the derivative of a function fx equals 3x squared minus 10x plus 1. Okay, so two lines that are parallel will have the same slope, and so all we need to do is to determine where the slope of the tangent line will be 4, the slope of the given line. In other words, we'll need to solve. Fx equals 4, 3x squared minus 10x plus 1 equals 4. 3x squared minus 10x minus 3 equals 0. The quadratic doesn't factor, and so a quick use of the quadratic formula will solve us for this. X equals 10 plus fractional point 136 divided by 6 equals 10 plus 2 fractional point 34 divided by 6, and negative 5 and equals 5 plus fractional point 34 and divided by 3. So the tangent line will be parallel to the y equals 4x plus 23 at x equals 5 minus fractional point 34 divided by 3 equals negative 0.276984. X equals 5 plus fractional point 34 and divided by 3 equals 3.61032. 3.61032. So that's how you do this, and Mrs. Burnth is going away for a while, so I'll see you guys then, I'll see you guys soon, and I'll see you guys later. Bye!